Morning. Good morning.
Good morning.
All right. Good morning. We've got our next step of our elements unit today. So we certainly try to break this up into many pieces for you guys to make it very digestible, but for your own sake, mentally you need to keep in the back of your mind all the stuff we've been doing because it does pile up over a while. So day one, we talked about what a limit was and how to find it from a graph. Day two, we talked about direct substitution and how to deal with 0 over 0 with factoring. And then last class, we talked about how to deal with 0 over 0 with conjugates and trig identities. Today we're going to do how to deal with 0 over 0 with complex fractions and piecewise functions. So again, this is really to give you an idea of what calculus is like, although it's usually much quicker in calculus. But as you guys have seen from the past few handouts, usually we spend very, very little, if any, time talking about the calculus, and most of the time talking about the algebra behind it. So it does pay off whether you do calculus or college algebra, either one. Those are things like conjugates are a big algebra topic. You just haven't had to use them very much. Okay, so on our notes here, we've got mostly a focus on complex fractions, but at the end there's a few piecewise functions, and then your other handout today is mostly practice on piecewise functions, which I can tell you for my students in calculus this year, piecewise functions is certainly one of the things that has held them back, not understanding how to work with and use those. So that will be important for you guys. All right, well, the first part's still the same. So we still always are going to try to start off with direct substitution. So we're going to plug it in. We're going to hope that we get a real number, and if we do, we can assume that that is our answer. That is still our first step. We're still working the same type of questions. We're just going to need new strategies for those same type of questions. Also, if you did direct substitution on here, if you have a number other than 0 and you try to divide by 0, you can't do that, so we say the limit does not exist. Basically been the same first two questions for 3 class periods now. That stuff is still true. But when we get something like this and we try direct substitution, we end up with 1/3 minus 1/3 on top, which is 0, and 2 minus 2 on bottom, which is also 0. So we need some way to deal with this 0 over 0. Make sure it's not the same one. So we've got a list of 3 things that we can think about that we've already learned. Factoring, doesn't look like it factors. Trig identities, there's no trig functions. And conjugates, but conjugates really need a square root in there. So this doesn't, as much as you may want to use one of those past techniques from the last couple classes, those are just not going to be an option. This guy is what we call a complex fraction. So again, it doesn't show up all the time in algebra, doesn't show up all the time in calculus, but you are expected, especially as high level math as you guys are, to know how to reduce these. So that is what we will do. We will practice making sure we know how to make this complex fraction look better. So what I really want to do in a complex fraction is I want to get rid of these smaller denominators. I've got 2 smaller denominators within a bigger fraction. A complex fraction just means you have smaller fractions within a big fraction. So what I'd really like to do is multiply this fraction by 3, because times 3 divided by 3 makes that go away. So I want that smaller denominator to go away. But if I only do that, then it's like I'm erasing this 3 and pretending like it's not there. To keep it algebraically equivalent, we have to multiply every term by 3. If one of them gets multiplied by 3, then all of them gets multiplied by 3. And what I'm really doing there is multiplying the top and the bottom of that big fraction by 3 and just distributing it at the top. So, of course, if I multiply the top and bottom of a fraction by 3, then it's like I'm multiplying by 1. Now, that's progress, but also there's one more smaller denominator. So I really want to multiply this one by x plus 1, because times x plus 1 divided by x plus 1 cancels out. But I can only do that if I multiply everything by x plus 1. So basically, we end up multiplying by the least common denominator within the smaller denominators. You don't have to think of it that way though. You can just do it one at a time. Get rid of this by multiplying everything by 3. Get rid of this by multiplying everything by x plus 1. Now, if you have sloppy handwriting like I do, you do need to make a conscious effort here to make your work legible because it gets pretty, quite a bit of stuff going on. But when these canceled, we were left with 3 times 1. When those canceled, we were left with a negative x plus 1. We need to distribute that negative. In fact, some people, usually a good idea for most students, I won't insist you do this, but if this is a minus, to just change it to plus a negative, because then it's a little bit easier to forget about, or harder to forget about, sorry. And in the denominator, we've got the 3 that we multiplied, the x minus 2 that was there the whole time, and the x plus 1 that we multiplied. So that step that I did in red and purple, the whole purpose of that was to make it not be a complex fraction. I no longer have smaller fractions within a bigger fraction. So it's really not that hard of a step. It's just that you guys don't practice complex fractions very often, so we're getting some practice in today. Now this question will finish just like the other limits that we did. It will finish with direct substitution, but direct substitution is not going to work until we get something to cancel. So I need to work with this numerator a little bit and see if I can make it look like an x minus 2 or an x plus 1 so that something cancels. So one thing we could do is we could say 3 minus 1 is 2. Now this almost matches up with this. What do they have? What's different about them though? One more time. Right, so one of them is being multiplied by a negative. Negative x positive 2, positive x negative 2, the exact opposite signs. So even though you may not think both of these have a negative, you can actually factor out a negative as a GCF anyway, undistributed negative. Then something cancels, then direct substitution will work. 3 times 3 would be 9. So that's the first type of question we're going to look at today. How practice reducing those complex fractions so that it's no longer a complex fraction. Then we got to work with it a little bit to get something to cancel, and then direct substitution should work. So start and end of the question are the same as we've done the last couple of days, but working with this mess to get it to that is our first challenge. Okay, so go down to question number 4. So if I plugged in a negative 7, 1/7 minus 1/7 goes to 0, 7 minus 7 goes to 0. This one is in indeterminate form. So I've got to make this stuff look better. Now again, you don't have to do all of this in just one step. Don't try to do too much unless you just really feel like you know what you're doing. But when I look at this, I know I want to get rid of this smaller denominator, and to get rid of a divided by x, I want to multiply by x. But that means everything needs to be multiplied by x if you're going to do that. How do I get rid of this divided by 7? Multiply by 7. If you multiply that by 7, everything needs to be multiplied by 7. And it gets a little messy, so be careful. But once these smaller denominators go away, then see what the aftermath of this is. We're left with an x times 1 here, a 7 times 1 there, and down here we've got a 7, an x, and a 7 plus x. Now again, the limit part is calculus specific, but even college algebra, they're going to expect you at some point to use simplified complex fractions. So that step is still good practice for you guys. Well, this one looks a lot easier to simplify. X plus 7 is the same thing as 7 plus x. The order of addition doesn't matter. The order of subtraction and division matters, but not addition or multiplication. So there's our canceling, and the second that something cancels, now we should be able to do direct substitution and get an answer. looks like negative 1/49. Okay, let's look at this next one as a group, and then I'll have you try the next one at your own pace. Okay, what is one thing that I should multiply everything by in question 5? Okay, I agree, because multiplying by 3 makes this go away, which is the purpose of that. But then make sure that everything gets multiplied by 3. And then somebody else, what's the other thing that needs to be multiplied? H plus 3 times divide, cancel out. But if one of them gets multiplied by h plus 3, all of them get multiplied by h plus 3. We've got h this time. Doesn't have to be x, it could be h, same thing. Then we got to see what's left over. So I did 3 times x plus h plus 2. Be careful not to just multiply h by 3, but also multiply 2 by 3. Everything gets multiplied by 3. Over here, negative 2 distributed to those. And then our denominator, becomes that. And now it is no different than what we've been practicing for days. We could combine some like terms in the numerator. Not much to do with the denominator, but something needs to cancel from the numerator and denominator. But the second that happens, then direct substitution is probably ready to go. 3 times 3 would be 9. But I'm most concerned about that first step. Seeing why we multiplied everything by 3 and why we multiplied everything by h plus 3. Okay, finish copying that one down, please, and then I would like you to try number 6. And I give you a couple minutes to do that. The other handout, that's the practice, does not have much of these, or many of these. These questions are just a little bit harder to come by. So we're mostly practicing complex fractions here, and you will mostly practice piecewise on the other handout. Okay, finished or not, let's see how you did, or see where you started to slow down a little bit. So at some point, you should have multiplied all of your fractions by 4. You can think of this guy as a fraction too if you want to think of them as over 1. So the real reason you're multiplying by 4 is to make this one cancel out. But then all of them get multiplied by 4. And then at some point, you needed to multiply all of them by x squared. And the reason you should have done that is because times x squared divided by x squared cancel out. And if we keep up with what we're doing here, we are left with potentially still a mess, but at least it's not going to be a complex fraction anymore. We're no longer going to have smaller fractions within our bigger fraction. So if you got that far, then you are good with the complex fraction piece. But of course, to simplify this limit without using a calculator and just looking at the graph, which is not usually an option, we got to get something to cancel here. So honestly, I don't know. If I try to work with this top, I see I could factor out a 3. I don't know if I should or not, but I don't really know what else to try. And then I also noticed that this is the difference of 2 squares. And now I think I see where this is headed. The only thing in the numerator that looks close to something in the denominator is the x minus 2. So just like a previous question, this is a positive x and a minus 2 in the denominator and the exact opposite in the numerator, positive 2, negative x. So you can factor out a negative out of one of these, which switches those signs. Just because they don't say negative on there doesn't mean you can't factor out a negative. Then positive x minus 2, positive x minus 2. Now those match up. You do just have to make sure you factored out that negative. So I tried to do that in red for you. And then finally that something is canceled. It looks like it is ready to go. Negative 3 times 4 and 4 times 4. And if we reduce, I would end up with negative 3/4. Okay, any questions about the end of that question? I will say that if you got stuck right here and you didn't know what to do, again, I didn't know factoring out a 3 and factoring out a difference of 2 squares. I didn't know that was going to help me, but I also didn't know what else to try. So sometimes you guys just have to force yourself to do something that you can see that works. Okay, so go ahead and make down any corrections you need to there, and then try one more time for me on number 7. So try to get further than you did on question 6. Does anyone recognize complex fractions? Did y'all do any of that in Algebra 2? No? Again, they're not too bad. It's just that it's one of those things that just doesn't show up much. So when you guys don't get much practice, it makes them harder than they really should be. finished 7 early. I'm going to be patient here to make sure this is the last one for people to try. So I really want people to try to work past where they initially get stuck. But if you're finished, you might try question 8 and see if you know what you should be doing on that before I explain it to you. Okay, let's see what happened in 7 and see if it looks like this one might be a harder question to finish at the end. But again, what is unique about this question is the smaller fractions within a bigger fraction. You should have multiplied everything by 9 to get rid of one of the smaller denominators, and multiplied everything by 3 plus x squared to get rid of the other smaller denominator. So over here, these two canceled and left a 9 times 1. Over here, these two cancel and you were left with a minus 3 plus x all squared. And down here, you had nothing cancel out. So you had the x that you started with, the 9 that you multiplied everything by, and the 3 plus x squared that you multiplied everything by. So if that step is not correct, then you did not deal with the complex fraction correctly. Okay, after this, I think I mentioned this in a last handout, but I know it is very tempting to say, well, let me just cancel out these 9s and then maybe cancel out these things as well. And as convenient as that would be, that's just not how fractions work. We can look at that with some basic numbers for if you need me to convince you of that. But you cannot cancel out terms. 9 doesn't get to just pretend like he's over this stuff and cancel out this 9, and then all of a sudden this guy's not over 9 anymore. He didn't cancel out with 9. So you cannot cancel out terms, only factors. Terms are things that are added or subtracted. So unfortunately in this question, it looks like we've just got to rearrange this stuff the best that we can and see what it comes out to be and see if anything will cancel. So what I mean by that is we could square this. So multiply it by itself twice. So FOIL. Again, I don't know. I did this question last year, of course, but I haven't worked this question yet this year, so I honestly don't know how this is going to play out, but I got to do something. If I distribute this negative, this becomes a minus 9, a minus 6, and a minus x squared. I just went ahead and distributed. Looks like those add to 0. These two both have a negative in common and an x in common. So if I factor that out, it's going to look like that. Oh, yes. Yeah. So I'm I'm expecting these to cancel, and so I was wondering if I had made a mistake somewhere. But really the one I need to cancel is if 0 is making the numerator and denominator 0, then 0 is the factor I need to cancel. So that's all that would cancel, and luckily that's all that we needed to cancel. So finally, we plug in 0 into what's left over, 6 on the top, 3 squared on the bottom, and then that reduces to 2/3. So not an easy algebraic finish to the question, but yeah, should be negative. Thank you. And that's just one other thing. Longer questions, more places for mistakes. By default, just makes the questions more difficult. So I feel like I'm at a disadvantage because I'm trying to think through it and explain it and write it out, but still, you guys need to see how easy it is to just lose a minus sign at the end. So again, you may never see a question that finishes the same way, but when you are at a place like this, what you need to learn out of this is that you know something needs to cancel. You can't cancel out terms. I didn't see how this was going to work, so I just did what I could. I FOILed to get these 3 terms. I distributed the negative, changed those signs. I combined like terms. I was just doing the only thing that I could see to do. I factored out a GCF, and then finally things just kind of fell into place. So you can't expect to know this is going to always work. This is always going to be step 1, this is always going to be step 2, and this is always going to be step 3, and then I have my answer. So sometimes you got to do what you can see, and go from there. Okay, so also just a quick reminder on these question types, this would be a little bit harder to graph in your calculator, but a good idea for a check, not an answer getting strategy, is if you graph the original equation in your graph, look at your graph on your calculator around x equals 0, see what it is as x approaches 0 from the left and as x approaches 0 from the right, and if those are the same number, in this case it should be negative 2/3, then that would be your answer. So anytime you have a calculator, you can use that as a backup. So I'm saying that because on the piecewise function, now this is not indeterminate form, this is just direct substitution, but it does require you to know a little bit about limits, and it forces you to know how to read this piecewise function, which is just something that, again, you guys don't get enough practice on. So what you have to know about limits, for the limit as x approaches 4 to exist, it better be exactly the same thing as the limit as x approaches 4 from the left and the limit as x approaches 4 from the right. If the limit from the left is not the same as the limit from the right, then that limit does not exist. So if I'm trying to find as x approaches 4 from the left, this is when x is slightly smaller than 4. So you can think of it as like, 3.9. Well, in a piecewise function, we've got 2 different functions. Sometimes it's this function when x is in these values, and other times it's this function when x's are in these values. So if I want to know the limit from the left, should I be plugging it into the top or the bottom? I think I heard both. This is saying when x is bigger or smaller than 4? Smaller. It always opens up to the bigger side, points to the smaller side. So this would be, for this question, the left side, because when x is less than 4, which is what x is as it approaches 4. So we would plug 4 in up here. 2 times 2 times 2 times 2 is 16. But from the right, this is when your x value is slightly bigger than 4, so you can think of like 4.1, just to give yourself an example. Then you got to ask yourself the same thing. You might still plug it into the top one. It just depends on what these restrictions are. But this is saying when x is bigger than 4, which is what it would be from the right. So on this one, we should be plugging it into the bottom. And 8 times the square root of 4 would be like 8 times 2, which is 16. And if the limit from the left is 16 and the limit from the right is 16, then the total limit, the limit from both sides is also 16. 16 is the answer to that question. Now, these are not formulaic. It's not that you're just going to always plug it into the top, get a number, plug it into the bottom, and get a number. You have to understand these piecewise functions more. Sometimes we're only going to plug it into one, and you got to know which one to plug it into. And but that's an important skill to have. So let's look at 9. So for this limit to exist, I need to test the limit as it approaches pi from the left. And I've got to test the limit as x approaches pi from the right. And if all of those are equal, then that is what the answer to the question will be. Now, from the left, this is when x is slightly less than pi. So, is it this top inequality or the bottom inequality that's saying when x is less than pi? The top, which is how you know to, for this part, to plug it into the top. The cosine at pi is -1. This is saying as x approaches pi from the right, so you need to think as x is a little bit bigger than pi, but getting closer to pi. And if x is bigger than pi, you should be plugging it in here. This is the one that's saying when x is bigger than pi. So if you plug pi into this equation, the sine of pi is 0. And if the limit from the left doesn't equal the limit from the right, this limit can't exist. So the answer to that is does not exist. Same thing we were doing on day 1, it's just that we have a piecewise function instead of a graph. We're determining what y value is approaching from the left, what y value is approaching from the right. If they're the same, that's the answer we get, like in number 8. And if they're different, then the limit doesn't exist, which is what happened in number 9. Okay, I would like you to try question 10 and see what you get. Okay, so if I only wanted to know the limit as x approaches -2 from the left, does that go into the top or the bottom? Top function or bottom function? Top, because that's when x is less than -2, which is what happens when you approach from the left. You plug that in. From the left, it looks like it's approaching -10. From the right, that's when x is slightly bigger than 2. This is saying when x is bigger than, or -2, sorry. This is saying when x is bigger than -2, so you should be plugging it into the bottom one for the right limit. -2 times -2 times -2 would be -8. Minus 2 more also gives you -10. And because the limit from the left is equal to the limit from the right, then the limit without a direction has to be both of those, and so -10 is what you were looking for. But you can't just get away with plugging it into one of them, as we saw in the previous question. If they're different from the left and the right, then the limit doesn't exist.
one's left and the right, or if they're just not the same, could you figure it out? Like if you were having trouble finding if they were left or right.
You need to know whether they're coming from left or right. In those questions, you would be okay, but let's look at your practice here. Let's look at question number 1. This one wants to know as x approaches -5. So, which one should I plug into for -5 from the left?
Top one.
Good. Because -5 is somewhere between -8 and 0. So if I plug that in up here, I get the sine of -5 pi, which I got to think about for a second. -5 pi is coterminal to -1 pi, and their sine is 0. What should I plug into to do -5 from the right? Very good. Still the top. The bottom is when x is between 0 and 10. For this question, if you care about as x approaches -5, and this is for 0 to 10, the bottom of this one had nothing to do with question 1. It's just there as a distractor to see if you really know how to read a piecewise function, and not that you're just plugging it into both of them and seeing what you get. So if I plug -5 into the same thing, I'm going to get the same value. And if the limit from the left equals the limit from the right, then that is your limit. So, using that as an example, it does matter if you understand which one it's coming from, because sometimes you don't even need one of them. So if you are just plugging it into both, getting numbers, and seeing if that's your answer, then you're not really reading the piecewise function the way you should be. Okay, the next set I'd like so you guys need some practice here, and these questions are also pretty hard to come by, so I need to get out of your way and actually have you try some of these. So let me give you a couple minutes to try 2 and 3. I will share the answers to those with you, and we can work both of them if we need to. And if we only need to work one of them or neither of them, then that's fine. And then I will ask you to do a bigger chunk next, and then a bigger chunk, and then a bigger chunk, and then we will be finished for today. Oh, also in question 3, I don't know if this printed out well for you guys, but can you see that 3 says x approaches -1 from the left? Can you see that little sign on there? No? Okay. Make sure you add it on here then. I was afraid that may not copy well. 3 is only -1 from the left.
So you only look for the left?
For that one, it's only asking for the left.
Are any of the other ones negative?
Number 4 is from the left. Number 5 is from the right. And that's it. I'll repeat those in a minute.
What does E stand for?
E is a number. Well, first let's check these, but I'll talk about E for a second. For number 2, I got -5. And for 3, I got e to the -1, which you could also write as 1 over e to the +1 if you use exponent rules.
It's the top one, not the bottom
Correct, because if you're coming from the left of -1, you want a number smaller than -1, and this is the one that's saying when x is less than -1. So yes, it has to be in the top one. Only the top one on that one because it was from the left. So the same way that pi is about 3.14, there's a number e that's about 2.719. They're both irrational, no repeating pattern. E comes up a lot with like exponential stuff and logarithmic stuff. Did you guys do like natural logs last year? Okay. All right. Well, natural log just means log base e. This number e just naturally appears a lot. The most common interest formula is PERT, P times e to the RT, and we'll talk about this in this class as well at some point this semester. But that number e there is right there. In fact, your calculator also has e programmed. E is very important. It's not the e, not that you need it for these questions or anything, but it's not this e above sign. That's the e if you're like writing a message. It's this lowercase e above divide. But anytime you need to work with e, second divide, it has that programmed in. Except I was wrong, this is 718. Okay, either one of these two you want me to go in depth on? Again, I don't mind doing both, yeah.
Does that say divided by r, the e?
This,
Yeah.
I just put it over 1 like a fraction.
Oh,
If you have a -1 exponent in your numerator, that's the same thing as having a +1 exponent in the denominator.
okay.
So usually most of the time in mathematics, a negative exponent is considered unsimplified. So we tend to write it like this on multiple choice, but I would understand why you might leave it like that on the last question. Okay, then next I'd like you to try 4, 5, and 6. But if you didn't hear me say this a second ago, again, I apologize, some of this doesn't print off well. 4 is from the left only, and 5 is from the right only. That just didn't print off well. So take a minute, do 4, 5, and 6, see what you come up with, and same thing. I'm happy to work all 3 of them if we need to. Otherwise, we can just focus on the ones that are causing the most issue. that long enough for those three? Okay, so number 4, I would plug it into the top because it's 3 from the left. So that would give me 9 minus 1, which would be 8. Number 4 should be 8. Again, I'll come back and do it in more detail if you need me to. Number 5 is negative 4 from the right only. So that's when x is bigger than negative 4, which would be the bottom. So you should get 2 to the negative 4, which if you want to leave it like that today, that's fine. But what I was saying just a minute ago, most of the time in mathematics, a negative exponent is considered unsimplified. So you can move it to the other side of a fraction to make it positive. And while you might not think that's important, in calculus it is important because our AP exam is multiple choice and free response. So if you never do that, then you never see your answer as multiple choice because they're always going to do that. And then 2 to the 4th just means 2 times 2 times 2 times 2, which I believe should be 16. So 1/16. Or if you just left it as 2 to the negative 4, that's okay too. And question 6. This doesn't say from the left or the right, so we have to make sure it's the same from both. So from the left would be the top, because that's when x is less than 6. That's what it's going to happen when you come from the left. So you would get 6 over 3 minus 2, which would be 0. From the right, x is going to be slightly bigger than 6, just heading towards 6. So that would need to be the bottom when x is greater than 6. So you should have plugged 6 into this and gotten the cosine of 6 pi. And what is the cosine at 6 pi? It is 1. So the answer to this one then is what? Does not exist. Limit from the left is not the same as the limit from the right. You might think it is if you're doing too quick with your unit circle. It's okay if you need to slow down and spend a little more time with the unit circle, but you do want to get those right. Okay, so before I ask you to try, let's see, 1, 2, 3, 4. Looks like there's 5 left, so I'll just ask you to try all 5 of those. Of these last 3, which of these would you like me to go back over slower and in more depth? Okay, then go ahead and try to finish up the last questions. We'll check them to make sure you don't have any others. I am asking that you turn in, you guys know I usually take up assignments on quiz days and test days, but this unit just kind of drags on a little bit, and I don't want you guys to be like trying to turn in 2 weeks worth of stuff at once, or even maybe 3 weeks worth of stuff at once. So I'll put it back up when we're done with this. But on the agenda page, I'm asking for the very first limit practice that you guys did. It's number 65. It was the one where we did the factoring. That's from 2 classes ago, so that should definitely be completed. But I will either take that in Google Classroom, or if you want to just turn it into the basket and have me look at it, whatever's easier for you. But I do want that turned in today before you leave. Does anybody need longer to check these last ones? Okay, so I'm doing this on the fly here, so speak up if you disagree with me, but it looks like from the left on number 7 it should be 2, and on the right it would be 4. Since those are not the same, number 7 I would say does not exist. Again, I'm happy to go over all of these if we need to. Number 8, looks like you should plug it into the top for the left and the bottom from the right. And it looks like they both approached -10, so I would say the answer to number 8 is -10. Number 9, -1 from the left would be the top, which gives you -1. From the right would be the bottom. 1 minus 2 would be -1. And since it approached -1 from the left and the right, that limit should be -1. Number 10, 4 from the left would be the top. 2 to the 4th is 16. From the right, you plug it into the bottom. Looks like 16. Left and right are the same, so that limit would be the same. And the last one looks like also needs to be plugged into both. The top, because it is as x approaches pi from the left, and the sign at pi is 0. And to the bottom, for the x approaches pi from the right, you plug that in, you get 1 minus 1, which is also 0. They're both the same, so that answer would be 0. Okay, any of those you want me to go over in depth? I will recommend that you look back at those questions. Those can be very easy questions, but you got to kind of look at them enough times to get it to click. So if it didn't feel like it was clicking and it didn't seem like they were easy to you at the end, then it would probably benefit you to look back at those questions again and try to make sense out of it. But that is all the practice we have today. So make sure you numbered your assignments. The notes we did today was 68, and then that practice worksheet we just finished up with 69. Then if you'd find 65 in your binder, that was the first day we dealt with 0 over 0, and it was only over factoring. And if you want to turn that into Google Classroom, that is fine, or you can put it in the box and I can get it back to you today. I would think that would be easier, but whatever you guys prefer. But I do want that before you leave in the next, 20 minutes. Should be more than enough time. Also, if you had any more CAP questions about math courses, then I would be happy to answer those too, especially since we have a little bit of time. I just hate for you to get half credit for 2 problems, but. to say that you didn't.